So in today's video, we're going to take a look at how to determine the equation of the normal line of a function at a given point. Now, the definition of normal, this just essentially is another way of saying the perpendicular line. So perpendicular, I think that's spelled correctly, yeah. And so essentially, what line is the normal line actually perpendicular to? Well, it's actually perpendicular to the tangent line at that point. And so here I drew out a particular function, which is f of x equals 3x squared minus 7x plus 1. I kind of just gave a little sketch over here. And I marked this particular point, 3, 7. And so essentially, if we were to kind of just approximate what the tangent line may look like, perhaps it will look something like this, kind of just scrapes the graph at this one point. And so what the normal line is going to look like, it's going to be perpendicular to the tangent line. So it's going to be normal to the tangent line. And it may look something like this, right? It's just going to intersect at one point at a 90-degree angle. And so the actual equation of a normal line is given by y equals -1 over dy dx times x plus b. And this -1 over dy dx, this term right over here, if you recall from the video we did on the equation of tangent lines, this is just the negative reciprocal of the slope of the tangent line. And we know, if you recall from our basic algebra 1 class and our properties of linear functions, we know that two lines are perpendicular if one of the lines has the negative reciprocal slope of the other line. And so in this case, we're taking the negative reciprocal slope of the tangent line, which is the negative reciprocal of the derivative, in order to actually determine the slope of the normal line. And so let's actually go ahead and determine the equation of the normal line of this function over here at this given point, at x equals 3. So let's go ahead and do that. So it would be very helpful, of course, to take the derivative in order to determine the slope of the tangent line. And so we would get f prime of x. If we use the power rule over here, we can get that the derivative of 3x squared is just going to be 6x. And the derivative of -7x is just going to be -7. And the derivative of this plus 1 over here is going to disappear because it's a constant, so it will be 0. And then if we want to actually determine the slope of the tangent line, because this is kind of just the equation of the slope of the tangent line, but if we want to find the particular slope at x equals 3, then we just have to input x equals 3 into f prime of x. And so we'll get f prime of 3, which is going to be 6 times 3 minus 7. And so what is this going to be? 18 minus 7, which is 11. And so what we're going to do now is we have the slope of the tangent line. This is what the slope of the tangent line at x equals 3 is going to be. If I didn't actually, I'm pretty sure 6 times 3 might, yeah, okay. And so this is the slope of the tangent line at x equals 3. And we know that the slope of the normal line is going to be the negative reciprocal of that. So let's actually go ahead and input that into our equation over here. This is the standard form, or not the standard form, this is actually the points, or this is the intercept form, the slope-intercept form. I don't know why I'm forgetting the name of these different linear functions forms. But yeah, this is the slope-intercept form, but there are many different forms for lines, obviously. So we're going to get y equals -1 over 11x plus b. So that's the general form of our normal line. And we know that we have to intersect the point 3, 7. This point has to be contained in our normal line. So we know that we're going to contain the point 3, 7. And that's just a property of the fact that we're kind of normal to the tangent line at this particular point. And so in order to solve for our intercept b, we just have to input 3, 7 into our equation over here. So we'll get 7 equals -1 over 11 times 3 plus b. And so we can solve for b over here. We'll get that b equals to, let me see what this is going to be. This is going to be 77 over 11 plus 3 over 11. And so this will be 80 over 11. These are some pretty ugly numbers. I probably should have tested this out before, but nonetheless, we have our intercept over here. It's 80 over 11. And so we can actually write out the full equation of our normal line. So the normal line is going to be given by y equals -1 over 11x plus 80 over 11. And so this right over here would be our final answer. And so essentially, the only difference between the normal line and the tangent line is just that we have to take the negative reciprocal of the derivative in order to get the slope of the normal line. And so essentially, I mean, if you remember your basic concepts from algebra 1 of when two lines are perpendicular or normal to each other, then one of the lines has to have the negative reciprocal slope of the other one. We can use that in order to actually determine what the equation of our normal line will be.